Hi, I'm Natalie Chardon, and I'm a PhD candidate in the Environmental Studies program at the University of Colorado, Boulder. And my dissertation focuses on examining the impacts of human disturbances in alpine environments. So one of my dissertation chapters specifically focuses on the Colorado Alpine, where I have about 18 field sites on various 14ers across the state. And I measure plant responses both on and off the trail to understand how human trampling affects these cushion plants. I specifically focus on the cushion plant Moss campion, which is Silenia caulis. It's a very long-lived cushion plant. It's pink flowering and has a taproot that lets it withstand these pretty hardy conditions out here. And by doing that, I can really get a snapshot of how disturbed areas look versus how undisturbed areas look. And as part of that, I've deployed temperature loggers across an elevational gradient on all these peaks to get a sense of if elevational patterns match the temperature patterns that we see. And it looks like I've reached one of my GPS points where I have buried a temperature logger that recorded temperatures here at around 13,000 feet on Quandary Peak over the last year. And let's see if I can find my temperature logger, which I've buried under my research plant, Silenia caulis. And there it is, year's worth of temperature data. The idea for this chapter stemmed from a pretty foundational research interest of mine, which is how and why species geographic distributions are the way that they are. So if you think about a species occupying a certain amount of space, say on a mountain or across a latitudinal gradient, the extent of space that it occupies is determined by a variety of factors. It can be pure climatic factors, say it's too cold on one end, too hot on another end. But it can also be factors that are driven by biotic interactions, such as if there's high competition on one end of the range and lower competition on another part of the range. And with climate change, we've seen shifts in species geographic distributions happening both upwards, as in northwards in latitudes, and also up elevational gradients, such as just species moving up a mountain slope. And pretty fundamental to that idea is that species are driven by temperature alone for the most part. And here in Colorado, in the Alpine, we actually get a huge impact factor by humans, given that popular 14ers get up to 300 visitors a day on a summer weekend. And I was really curious how the impact of human disturbance played together with these climatic conditions. So although my study doesn't span many years worth of data, which would actually allow me to see if species are moving upwards in elevation or how the temperatures are actually changing, what I've done is I have set up plots at 3 different elevations on each of my 18 14er sites to see how the cushion plant Silenia caulis I'm studying is responding to disturbance at each of these plots, what the temperature is at each of these plots, and what the surrounding vegetation looks like. And so, in summary, this basically lets me see if the vegetation is really getting altered by trampling disturbance at lower elevations, but maybe not so much at higher elevations. And I'm seeing an according response in the cushion plants, then I might be able to conclude that trampling is really affecting the biotic interactions, the lower elevational range limit of Silenia caulis, versus at upper elevational range limits, where there isn't really that much vegetation, you would expect competition to be quite low, and the species range to be more driven by abiotic factors, so things like temperature. And so up here, I think that trampling would actually have a pretty negative effect, because it's you get trampling, you get pretty harsh climate, and in total that just gives you this pretty net negative effect on the cushion plant Silenia caulis. And the reason I'm deploying these little temperature loggers, which I store in these silicate cases so they stay nice and dry for the year, is to actually confirm this assumption that at lower elevations we have warmer temperatures and at higher elevations we have colder temperatures. Considering that most of our climate data is gathered at climate stations that are potentially very far away, they're higher up off the ground. This actually lets me see what the microhabitat temperature is at these various sites. So here we are at my uppermost plot on Quandary Peak, and I have trailside plots that I set up last year and the year before, and off-trail plots that I also set up to again get the snapshot of what do disturbed Silene-Collis populations look like compared to undisturbed Silene-Collis populations. And I have this sort of pair of plots at 3 different elevations on each of my mountain sites. And to give you an example of how negatively affected cushion plants can be affected at these high elevations is this guy right here, which you can see has been completely trampled over by hikers not staying on the main path. You can see dead rosettes here, which are the way that cushion plants increase their diameter, and that's how we actually measure growth. We can see here that there's absolutely no reproductive structures on this plant, and they've probably also been trampled away. And this is a plant that used to be about this big, and it's now much, much smaller. Here we are at my lower elevation plot here on Quandary Peak, and this was my trail side plot that I sampled, and my off-trail plot was at least 10 meters away from the trail. And what's very different at this plot than the upper elevation plot is that there's a lot more vegetation growing here. And the cushion plants themselves at these lower elevations seem to be affected by trampling, but not quite as negatively as they are at upper elevations. Part of the reason might be that the surrounding vegetation to cushion plants might be getting trampled away, therefore reducing competition for habitat space. But those are analyses that I'm working on right now in order to finish up this chapter and produce a publication. This entire project has been funded through various different sources, and I have to thank the Indian Peaks Wilderness Alliance for their very, very generous support and for this field work, which takes a lot of driving around the state of Colorado and deploying the eye buttons and other field materials that I've needed. So thank you very much for your support.